let's go over the definitions to start, because 3.3 is all about solving a system of equations. But do we really know what a equation really is and how this works and all the definitions involved? So I figured we would start at square one. What is a graph? A graph of a line is a visual representation of all the solutions of an equation. And I've got an example here that I have graphed the equation 2x plus 3y equals 6. And we can see it as a blue line. So every single point on this blue line would count as a solution of that equation. So at any given time for a equation, a single equation, you have, in fact, an infinite many solutions possible. All right, but that changes when we start talking about a system of equations. So not just one equation, but two or more. Well, if we did that, we would be trying to graph two lines on the same grid. So in this particular lovely example that you can see here, we have a line of x plus y equals 50, which is this one. And then we also have the x equals y plus 20, which is that one. All right.
Can you scroll back up so I can finish the graph or no?
Sure. Okay, so when we are solving a system of equations, we have two lines on the same grid. And for a solution of a system, since we're not talking about just one line anymore, we're actually talking about two lines, the solution of a system is where these two lines intersect. So for this particular example that we see on our screen, our solution is that 3515. All right. It is where the two lines would intersect. Now, we will learn more how to do this ourselves, of the lines and the graphing and stuff, in chapter 2, next unit. For the moment, we want to figure out how to do this algebraically. So we want to do it by hand, but we don't want to do it with the lines. And we will talk about that in about 10 minutes. So there are three types of solutions for a system. We have the actual solution itself, which means they have a definite intersection of the two lines, and we can write that down. But we also have two other options. The lines could be parallel, meaning that they actually never intersect ever. Because of that, you would have no solution. The third option is if the lines are actually the same line. Well, if they are the same line, they are right smack dab on top of each other, and every single point will intersect with itself on the other line, and thus you have infinite solutions. So there are options. Most cases, 90% of the time, we will only have one solution, one intersection point, and that'll be it. But every now and then, we'll have the other. Okay, so I thought a visual representation of these definitions would be easiest to understand. So that's why I did this. But what we are going to learn how to do in this section is how to find the intersection, the solution, algebraically, not graphically. So let us have some options. There are four basic methods of finding a solution to a system. And one is, well, to graph the thing, all right? We'll get there. The second method is called the substitution method. So we would be literally substituting one equation into the other equation. So let's have an example. Okay, so let's solve a system using substitution. So let's have 9x plus 2y equals negative 11. And y equals 2x plus 1. All right, that's the system that we're going to be working with. So substitution, it has its purposes, it has its uses. In particular, it is most useful when you have something like y equals or x equals and everything follows after it, as the example that you're seeing now. So when we do this, we are going to take the lovely thing that they gave us, in this case, the y equals part, and we would substitute it into the other equation. So something like this, we would have 9x plus 2, and then we would substitute in the 2x plus 1 for the y equals negative 11. And then we would solve from here. Because we don't really know how to solve for two variables at the same time yet. We'll get there. For the moment, we only know how to solve for one variable at a time. So we have to do something to finagle things and mess with them, so we're only looking at one variable at a time. Substitution is one of those methods. So once we've got the substitution part, we would solve our equation. So get rid of the parentheses. How do we get rid of parentheses?
We multiply everything by the 2.
Very good. All right, so we would get 4x plus 2. Now what?
Subtract 2 from both sides.
Okay, so that would give me negative 13 on my right. What about on my left?
You'll add 9 and 4. That'll give you 13.
Mm-hmm. Give me 13x. Now what?
Divide by 13 on both sides.
So we get x equals
Negative 1.
negative 1. Once we know one of our variables, in this case x, we can substitute it back into the equation. So in particular, I would want to substitute it into the other equation, the y equals 2x plus 1 part. So I would take this lovely thing and I would substitute it in. So we would get y equals 2 times that lovely -1 we just found, plus 1. So we get y equals 2 times -1,
-1. I mean -2.
-2, plus 1
It'll come out -1.
is -1. And the fact that those are both the same number is complete coincidence.
Can you? I actually forgot we had the equation for y equals. So I plugged it back into the original equation, the 9x plus 2y equals -11. I still got -1, but can we do it both ways?
You can. The reason why you want to do it into the other equation is just to make sure. It's very easy for oopses to happen.
Okay.
Now I'm not quite done. My math is perfect, but I need to put my answer in the correct format. So my solution, I'm going to write it like this. I'm going to write it with parentheses and then my x number first, comma, my y number, and parentheses. All right, x number first, then the y number. This is called an ordered pair. It is the intersection of those two lines. Okay. Questions? Okay. The second method is called substitution. There is a third method. So let's say we had the system 2x minus 3y equals 0 and -4x plus 3y equals -1. Now, just by looking at it, I can tell that substitution is not going to be my friend. I don't have a y equals equation. I don't have an x equals equation. I've got both of my variables on the left side of my equal sign. So substitution is not going to be my favorite method for this. So instead, we are going to use something called elimination by addition. Mathematicians being uncreative when it comes to naming things, elimination by addition is when you are going to add the two equations that they give you, and we are going to eliminate a variable. Okay. So we're going to add these two equations together for the sole purpose of eliminating a variable. Which variable do you think is going to be eliminated, X or Y?
Why?
Y?
Because y has a -3 and a +3. So if you add those together, you don't get 0.
Exactly. One's positive, one's negative, and they have the same number. So yeah, we're going to eliminate Y with this. Let's do so. So add these lovely things. We're going to get 0 for our y, which makes it disappear into the ether. Yay. We also have 2x minus 4x, so that would be minus 2x. And then 0 plus -1, which is -1. Solve for x.
X equals 1/2.
We divided by -2 both sides. So we get x equals negative divided by negative is a positive. So we get x equals 1/2. Yay. But we're not done because we also need to find y. So we're actually going to do the same thing we did in our previous problem. Now that we know what x is, we're going to substitute it in to one of the equations. Which one?
It doesn't matter.
It doesn't matter. You got it. Which one do we want to do? Top or bottom?
The top.
All right.
Because it's all positive.
Yeah, that's kind of what I was thinking too. So 2 times 1/2.
1.
1. Minus 3y equals 0. So what I'm going to need to subtract 1, both sides.
-3y equals -1.
And then
Divide by -3.
both sides. So we get y equals
1/3.
1/3. Yay! Last but not least, we need to put our answer in the correct format. So our solution is 1/2, comma, 1/3 with the parentheses, just like that. X number first, Y number second. What you think? Is this easier than substitution?
Yes. I feel like it's the same.
It does have similar elements. Yeah, we still have to do that substitution step on the second part.
It really just depends on the problem, I guess.
It depends on the problem. You just hit the nail on the head, my dear. It depends on what you're looking at. Some of them are way easier. This one was way easier, but that's not always the case. Let's do another one. Let's have x plus 3y equals 7 and -x plus 4y equals 7. Okay, so just looking at the system that they gave us, just looking at the system, what do you think would be easier, substitution or elimination by addition?
Addition.
Addition. Why?
Because the x's will equal or cancel out.
Exactly. The x's will cancel out. Say it again, sweetie.
I think it was just someone's computer.
Okay. Well, let's go ahead and add them, shall we? So positive 1x minus 1x goes to 0x, vanishes into the ether. 3y plus 4y is 7y, yes?
Yes.
And then on the other side, we get 7 plus 7, 14. And what's y?
So 2.
It is indeed. Divide 7 by both sides, and we get y is 2. All right. So now that we know one variable, we know that y is 2, we can use substitution to figure out what x is. What you guys think? Which one? Top or bottom?
Top one.
All right. So x plus 3 with that lovely 2 that we just found. So we get x plus 6 equals 7. So what's x?
6.
Mm-hmm. Subtract 6 both sides, we get x equals 1. Write our solution as an ordered pair, which is what this is called. And we're done. Oops. I made a mistake. I made an oops.
Put y before x.
Yes, I did. I put y before x because we found y first. Oops. That's wrong. X always goes first.
So I have a question.
Yes, sweetie.
Okay, so whenever you're solving for y and x, so do you solve for like y first and then you do the equation again and then you solve for x? Is that how you were doing it?
We added the two equations, which eliminated our x variable. So we found y first, and then we used substitution to find x.
Oh, okay. So you put 2 in for y and then once
Yes.
you figured out what that was, then that equals x, correct?
Yes.
Okay. Okay. Thank you.
You're welcome.
Oh, I have a question. This probably doesn't have nothing to do with what we're working on right now. But on Monday, when we were doing the less than or equal to, and
Mhm.
whenever you were flipping the signs, I got confused on that. Like, I didn't understand why you were flipping the signs.
You only flip the sign for inequality if you are multiplying or dividing by a negative number.
Okay, so it's only if you're multiplying or dividing. It's not like subtracting or adding.
Correct. And it's only multiplying or dividing by a negative. It's not just multiply or divide, it's by a negative.
Okay, so it has to be a negative in order to flip
Yes.
the sign.
Yes.
Okay, that's why I kept messing up on the homework. Okay, thank you.
You're welcome. All right. We want another example.
What's the other option?
What's what other option? Option for what?
You said, do you want another example?
Well, the other option would be to go directly to your homework without the rest of the things that I had planned.
Oh, I would love another example.
Hold on a second. Okay. So let's say that they don't give us a choice. They specify using elimination by addition. All right. If they specify a method, you have no choice. You must use that method to solve. All right. And let's say we had 5x plus 3y equals negative 11 and 3x minus y equals negative 1. Okay. So they're telling us point blank, you must use elimination by addition. So we know we're going to add these two, but if we added them as they are, we would get 8x plus 2y equals negative 12. Does that help us? Does it eliminate a variable?
It doesn't, but you can simplify that equation from where it is.
It's not helping us at all because we still have two variables. The whole point of elimination by addition is to add the equation and delete a variable. So we have to do something to these two equations, or even just one of them, so that we can add them and eliminate a variable. So let's see here. We have x, and x has 5 and 3, and we have y has positive 3 and negative 1. Which are closer together? I mean, which would be easier to work with, the 5 and the 3 or the 3 and the negative 1?
Would it be the 5 and the 3?
3 and a negative 1.
I'd do the 3 and the negative 1. So why? Well, it actually goes back to why we picked, oops, over here for our second example. We said that the y was going to eliminate itself because one was positive, one was negative, and they were both the same number, right? So that would go to 0y and disappear just the way we wanted it to. So if we used the 5 and the 3, we would have to do something to both equations so that the 5 and the 3 actually matched, and we would have to make one of them negative. Whereas if we look at the 3 and the negative 1, one's already negative. So it's like eliminating a step.
So does that mean we're going to have to multiply the whole equation by something?
You got it, my dear.
Oh, goodness.
You got it. So taking a peek, remember, did we talk about LCDs in here? I don't remember.
Well, we did. Yeah, we did.
Okay. So looking at the 3 and the negative 1, what is their LCD or LCM, depending on who you're talking to?
It's got to be 3, right?
Yeah. I mean, the first number that 3 and 1 have in common is, well,
Yeah.
3. Which also means, makes it much easier on ourselves because multiplying by only one thing. So we want that 3 on both top and bottom of our y's. We already have that in the top, so I'm not going to mess with it. I'll just rewrite it over here. But we're going to have to mess with our bottom because it only has the negative 1. Yay for the negative, but I need that to be negative 3. So as the lovely lady said, we are going to end up multiplying. What am I multiplying by?
3.
3. I got to multiply by 3 everywhere. So 3 here, 3 there, and 3 there. So that gives us 3 times 3 is
9.
9x minus 3y, exactly the way we planned it. And then we got 3 times -1, which is -3. Now we can add them. So 5x plus 9x is 14x. 3y minus 3y is 0y, vanishes into the ether. And then -11 plus -3, -14. So what's x?
Oh no. It's 1.
-1.
-1. Divide both sides by +14, and we get x equals
Hello.
-1.
Hello.
Hello? Now that we know what x is, we can substitute it into one of our original equations. Take your pick, top or bottom.
Bottom.
All right. So we got 3x minus y equals -1. I'm using the original, not what we turned it into, but the original. So we get -3 minus y. Add 3 to both sides. So minus y equals -1 plus 3 is +2. So what's y?
-2.
Mm-hmm. Divide by -1. So we get y equals -2. Write it as a lovely ordered pair. X number first, then our Y number,
I have a
and
question.
crowd goes wild.
I have a
Question, yes.
Whenever we were on the right side over here and you said to choose between which problem, like to do with Y, I think does it matter which one we pick?
Technically, no, but some are much easier than others. In this case, it pretty much set up to do Y. In our next example, you can pretty much take your pick.
Is there a way that you would get the wrong answer if you picked the wrong problem?
Not a
Or
bit.
no?
Not if
Okay.
your math is correct.
Okay.
The biggest thing, so just for the sake of argument, let's say that in this example 4, we decided to eliminate x instead. Well, what would be the LCD? 15. So we would actually end up multiplying both equations by a number instead of only one equation. And one of those equations would have to be multiplied by a negative. Wouldn't matter which, but it would be the only way to add to eliminate X. Does that make sense?
Yes, ma'am.
Okay, let's take a peek at our next example. Once again, they're specifying the method that we have to use to solve it. And this time, take a look at our numbers here. We have 3x, 3y equals 15, 2x, 6y equals 22. They're all positive. So which variable would be easier to eliminate?
It'll be easier to multiply the top equation by -2.
It would. Why?
To get the common denominator or the common multiple of 6 between the equation for the y.
Yeah. If we did the y here, our LCM would be 6, and we would only have to multiply this top equation by -2. As opposed to the x here, our LCM would still be 6, but we would have to multiply both equations, one by 2 and one by 3, one positive, one negative. So how we choose which variable to eliminate is based entirely on the numbers that we see, which we would rather work with. Okay, so let's see here. We want to multiply our top equation by -2, right? So -2 times, -2 times, and -2 times. So we get -6x minus 6y, careful of there, -2 times +3, and -2 times 15, which is -30. I'm not changing my bottom one, so I'm just going to quickly rewrite it. And now we can add them. So -6x plus 2x would be -4x. The y's, those go to 0y, which vanishes into the ether, exactly the way we planned it. We planned it that way. Equals -30 plus 22, -8. All right. Divide by -4, and we get x equals +2. Yay! Once we found the first variable, we can substitute into one of our original equations. I'm going to pick the bottom one this time. Why did we multiply by -2? Because the smallest number that 3 and 6 have in common is 6 itself. The bottom equation it already has 6y. So in order for our top equation to add to the bottom equation to get 0y, we have to have one of them to be negative. So we can't just multiply by 2, because that would still make our top equation to be a +6. And then when we added, they would be plus 12y, which doesn't help. You're very welcome. So 2 for the x and solve for y. So 2 times 2 is 4. Subtract 4 both sides. So we get 6y equals 18. Divide by 6 both sides. So we get y equals 3. And last but not least, writing it as an ordered pair. So 2 and 3. Questions? All right. Please put the Zoom word into the chat menu. And let's have 2x plus 3y equals 17 and 5x plus 7y equals 29. All right. Which variable do we want to eliminate?
It'll be easier to eliminate x because 5 and 2 have a closer denominator of 10 or closer common multiple of 10.
That's one thought. It's not a bad solution, not a bad idea. But if you take a look, we've got 3 and 7 for our y's, and we've got 2 and 5 for our x's. No matter which variable we pick to eliminate, we're going to end up multiplying both equations anyway. So in my opinion, it doesn't really matter. Pick one.
Bottom.
Bottom?
Yes.
What do you mean by bottom, sweetie?
Did you say that you said it one? Or did you mean the one that highlighted?
We're trying to eliminate a variable.
Oh, okay.
Okay. So -2 times 7 would be -14y. And 29 times 2 is -58. All right. Oh, that actually worked out rather well, didn't it? Add those. The x's cancel just the way we planned them to. And then we have 15y minus 14y, which is 1y. So 85 minus 58 is 27. And now substitute. I think I'm going to use that first equation because the numbers are smaller. Let's see. Definitely need our calculator for this one, huh? subtract 81. Got 2x 17 minus 81, negative 64. Divide by 2. We get x equals negative 32. Big numbers. Okay, let's do the exact same system, but this time let's eliminate y instead. Okay, so our LCM here would be 21. And we would still end up multiplying both equations. So this top equation, I would multiply by 7 to get that 21 on the y's. So that'd be 14x plus 21y equals 7 times 17, which is 119. And then for our bottom equation here, to make sure that we eliminate y, we would have to have negative 21y. So to that, when we added, we would get 0y. All right. So what would we have to multiply our bottom equation by to get negative 21y?
-3.
Negative 3. There you go. So 5 times negative 3 is negative 15x. Negative 21y, just the way we planned. And 29 times negative 3, which is negative 87. Okay. So we add 14x minus 15x, which is negative 1x, and 119 minus 87, which is 32. Divide by negative 1. So we get x equals negative 32. And once we have one variable, substitute it into one of the original equations. You'll get the same exact answer either way, whether you wanted to eliminate x first or wanted to eliminate y first. Your solution is the same, and we would find it the same way. Multiply, add, and then substitute. The only difference really is, what are we finding first? Questions? Okay. how about 2x minus 4y equals 5 and 2x minus 4y equals 6. Hmm. They're almost the same, right? They're really close. But if we went ahead and added them right now, it wouldn't help. One of them has to be a negative. Which one? Top or bottom?
The top one.
All right, top one it is. So negative 2x plus 4y equals negative 5. And we're not doing anything to that bottom one. Adam. Ooh. Aha. So negative 2x plus 2x is 0x. And 4y minus 4y is 0y equals negative 5 plus 6 is positive 1. So what are we getting here? 0 equals 1. That doesn't look right, does it? That definitely doesn't look right. What you think? Is our math wrong?
No, it's like you just physically can't do it.
No
Yeah.
solution.
Our math is fine. We eliminated both variables and, excuse me, guess what we just said? We eliminated both variables. And this is false. Somebody said it. So it is a false statement. We eliminated both variables. Therefore, there is no solution. Both variables disappeared. We have a false statement. 0 does not equal 1. Therefore, we have no solution. Don't come up often, but they do come up occasionally. Okay. One more and then I'll shut up. So let's have let's have 3x minus 2y equals 1 and negative 6x plus 4y equals negative 2. All right. So what variable would we like to eliminate? All right, y it is. So if we are eliminating y, then our LCM is going to be 4, which means my bottom one is not going to change at all. And it also means that I am going to have negative 4y so that they cancel and go to 0y, just the way we want them to. So what do I need to multiply this first equation by to get negative 4y?
-2.
We already have a -2 there. This lovely -2. So -2
You must-
times what will give me -4?
2.
+2. There we go. So +2, 3 times +2 is +6x. 1 times 2 is 2. Ooh, here we go again. So 6x plus -6x, that's 0x. And 2 minus 2, that's 0. So we get 0 equals 0. What would this mean?
Infinite solutions.
Infinite solutions. Very good. This is a true statement, and both of our variables are gone. So we have infinite solutions. Questions? Okay. I am